Welcome back.
All right. Our next presenter all right, is Thomas, pardon me, Norway 7 United Sugar. Welcome to the party, Thomas. Thomas is a contributing editor for CQ Magazine, focuses on propagation, and we're so glad you're joining us today. We hope you have some great news about Solarycle25. So I'm going to turn the stage over to you. Stop sharing. You can bring up your video and your audio, and the stage is yours.
Are you there, Tomas?
Yes, can you hear me?
I've got audio, and then we just got your photo so far.
Right. It tells me that I cannot share my video because the host has stopped my video.
Let's see. You have full privileges to share your video. So what's happening when you click the green share screen button? There you go. Something's coming up. Okay. All right.
Well, you're not seeing me though. I suspect.
Not seeing you.
We see your desktop right now.
Well, that's good enough. I can be invisible.
And if you can speak up, that would help.
Sure. And I will try to get my audio to increase a bit here too.
That would be great.
Let me see if I can't do that right quick. How's this? Any better?
Much better.
100% better. You're 10 over 9 in San Jose.
All right, perfect. Well, I am Thomas. I pronounce it Thomas without the H, just not Thomas. And I am November Whiskey 7 Uniform Sierra. Got my call sign when I was living in Seattle or near Seattle. And I love the Northwest 7 land of the United States. Therefore, I figured a good DX call would be the NW7US. At the time that I got it, NW was an uncommon prefix, and I thought maybe that would give me a little bit of advantage during DX pileups. And lo and behold, it has become somewhat helpful, I believe, because people really seek after the NW prefix. It's unusual. There are more of us out there, however. One of my best friends is NW7NA, for instance. So yeah, the presentation that I'm giving you now is indeed something to give you a little bit of hope. I'm going to stop and just tell you first how I became a heliophile. And heliophile is lover of the sun, or a sun lover. In the first decade of my life, I discovered a portable radio in my parents' room. It was a little Sony radio, a little 4-band portable radio. So I snuck it out of my parents' room and out into this large field, and I extracted the antenna, and I turned knobs, pulled knobs, and discovered how to turn it on and get the volume. And I started tuning around. And of course, I found the FM band with local FM radio, and I found the AM band with its local, stations. But then there was this SW, and I had no idea what SW stood for. And I tuned around that at different times, usually during the day, and I discovered different sounds, pops, squeals. Mickey Mouse Talks, and the station called WWV from Fort Collins, Colorado. And I thought, wow, I'm up here in Montana and I'm here in Colorado. That's pretty cool. And eventually I started to discover a consistently hourly broadcast about sunspots, geomagnetic activity. And I really scratched my head figuring out what could they be talking about. So a library search came with some books, and I discovered a little bit more about our Earth, the fact that we have this magnetosphere around the Earth and a geomagnetic field. And I discovered that we have a sun that has cycles and features called sunspots. And there began my love of the science and the magic of both shortwave radio, ionospheric propagation, and space weather. Now, at the time, they didn't call it space weather. That's kind of a new term now in the modern age.
Tomas, this is John. Let me interrupt.
Thomas,
Tomas, you need to really need to
don't
share.
mean to interrupt, but can you try unsharing and share just your presentation
Right,
screen?
right,
You're currently sharing your whole desktop.
right. We're only seeing half of the slides that you want to show. So if you're using PowerPoint, put it in slideshow mode, and that should help.
Do you see that change?
Still not quite right. Your desktop's in the background. We want you to. Are you using PowerPoint?
Don't share your desktop. Share just the application screen from the presentation program.
Yeah, you can stop sharing and start again if you want to do it that way.
So let me figure out why.
Yeah.
Stop sharing and then
stop sharing.
Okay, that's PowerPoint. I'll put it in slide mode.
Right now, share, when you hit share screen, you'll see. Don't share the whole screen, just the window with your presentation.
Just the power.
That's odd. I must have hit the wrong one, though. Yeah. That's
it makes
mistakes happen.
That's okay. We want to make sure we see your beautiful slides.
I would imagine that's this then. Is that any better?
There you go. That's better.
Well, anyway, you heard a little bit of an introduction of how I got started with this. I believe radio is magic, and I love to share the magic with everybody that I can possibly share. And George Jacobs, who used to write the column in CQ magazine, discovered that. And Rich from CQ magazine and George, the column writer of the propagation column, reached out to me around 2001, asked me if I could take over for George since George was retiring. And I've been writing ever since. So with that, let me turn that off. That was to be used earlier. Throwing our voice around the world, that's the magic of the ionosphere. And some of you that have joined us know that, you're old DXers. You've been around at least one Sunspot Cycle, maybe 2 or 3. And you know about space weather, but a lot of you might be new. You're a new ham and you've heard about sunspots and the Sunspot Cycle. And you may have heard a little bit that, hey, we need a sunspot or two to make our 10-meter band come alive. So with that, I want to talk a little bit about space weather and why it's important. And I'll use an analogy. You know, many ham radio operators don't think much about space weather, except when they can't talk on an HF band, like 10 meters. You tune around and you just hear hiss, or you may hear occasional static crashes, but you hear nobody. Maybe once in a while you'll hear somebody locally on 10 meters and you wonder, why is this band dead? Do I have a bad radio? Do I have a bad antenna? Is it something that I'm just in a bad location, or is this ham radio bunk? And you get discouraged. Well, it's similar in a way when you go fishing and you take out your rod and your lure and you go out to this beautiful spot, you sit on a rock and you cast, and there's no fish and no hits, and hours go by and there's no dinner. And you wonder, what the heck? I thought this lake had some fish in it, right? Well, it's the same way with DX. You kind of have to know if you have some tools, or maybe, like in fishing, you have a little radar thing that, or sonar thing that tells you where the school of fish is as you cruise out on the lake. You kind of have to know where the fish are, what time of day they're feeding, what lure they're using. And space weather is kind of the same thing. DXing on 10 meters, you have to know the right time of day or maybe the right year, because things change. DX propagation doesn't stay always on the same spot. It's variable. And why is that? Well, the reason for that is the sun is variable. The sun puts out more energy at some points and puts out less energy at some points. And so we rely for DXing, fishing that DX, on what the sun is doing. But we have tools and we have research. We have decades of research about how the sun works, how our ionosphere changes based on the radiation coming from the sun, and how radio waves refract through that media. In the last few years, I'm hearing a lot of discussion, not just in ham radio discussions, but in TV broadcasts and newspapers, that the sun is waking up and sun flares are heading to the earth, and explosions on the sun might take out our grid, our power grid, our gas pipelines. And so a lot of talk is happening. It happened the last cycle as well. As a matter of fact, in the last cycle, we even heard we're going to have a mini ice age. And the reason for that is because the period between the 23rd cycle ever recorded by man and the 24th cycle was a very long, what we call quiet period. And quiet means there were no sunspots, none, not even a speck on the surface of the sun, day after day, week after week, month after month, actually year after year. And it was a really prolonged period. Most of the people that witnessed sunspot cycles expected maybe a year between 23 and 24. But no, year after year went by, 3 in total, and there were no sunspots. And people began to worry. So there was a lot of speculation. And we had a lot of speculation again when sunspot 24 began to fade away, activity died down, and we got into that minimum period. But gladly, we just picked up activity in the last 4 to 6 months, and we're starting to see sunspots again. And so we're interested. Where are we? And when will my 10-meter band wake up? When will I have this amazing worldwide ability to make contacts with a wet noodle radio somewhere in China, and I'm over here on the East Coast, and I want to make that DX that I heard could exist on 10 meters, because these old timers tell me there used to be magic on 10 meters. It's dead right now. So when will our HF bands improve? Again, space weather is important to us. So the key to answer that question is, what's the sun doing? A refresher, I'm going to just digress a little bit on, because some of us might be new and you're not familiar with how, for instance, 10 meters comes alive and why it comes alive. So let's digress just for a moment. HF technically is 3 megahertz to 30 megahertz. And of course, 10 meters is 28, 29, is 28 to 30 megahertz at the very top of the shortwave band, top in terms of the frequency number. The old timers will say the top band is actually the larger band number, meaning wavelength. So 160 is the top band because 160 is the larger number, 10 meters is the lower number. So that's actually shorter and therefore down the band. The top is 160. But in terms of talking frequency, at the top of the shortwave spectrum, around 28, 29 megahertz, that's just before we get to very high frequencies or VHF. And of course, 6 meters is in the VHF band. So we rely on this layer of our atmosphere that's called ionosphere. And that ionosphere is what we use to refract our signals from our radio on shortwave to some far distant location. Imagine for a moment you're in a dark room with a flashlight. You got the flashlight on, and there is a mirror on one wall. You're standing at an angle of facing that mirror, and you shine the flashlight at the mirror, and you notice that the beam of that flashlight bounces off that mirror at an angle, and the takeoff angle puts your flashlight beam's circle on a far wall. So it's bending, it's reflecting that beam. In a similar way, we bounce or refract our HF signals off of the ionosphere. But the ionosphere is not always capable of refracting that radio signal, that flashlight beam. The more the solar energy, the more energized the ionosphere and the higher the frequency that we can propagate via that reflector. So if we want 10 meters to come alive, we need a very great amount of sunspot solar radiation. If we just have a tiny bit, maybe 1 or 2 sunspots, the chances of the ionosphere being energized enough to refract a 10 meter, 28 megahertz signal is pretty low. It may not happen. During the day, if there's too much energy, the HF radio signals may be absorbed by the ionosphere, especially in the lowest part of that region, that whole region. There are sub-regions. We call them the D layer or the E layer, the F layer, and the F layer splits between 2 to 3 layers. And the D layer typically absorbs radio waves in the HF spectrum. The more energized the D layer, the higher in frequency the HF signals that get absorbed, blocked. That's why AM radio stations, for instance, disappear after the nighttime well, in some cases worldwide, but at least regional DX on AM bands, that disappears because the D region wakes up with the sun's radiation at dawn. Okay, with that, if the sun is quiet and there's no sunspots, there's very little energy. So the D region will absorb the lower part of the HF, but the higher HF has very little absorption. However, the higher regions, which refract signals, they won't energize enough for the highest portions of the shortwave band. The HF bands from 17 meters up to 10 meters could be completely dead because there's very little activity. But when the sun wakes up and there's sunspots and that energy increases, 17 meters and up begin to propagate. And at the same time, the D region energizes a bit as well. So the lower frequencies, like up through 40 meters, maybe even 30 meters, certain paths could become attenuated and there's a blockage. So that's what we've been seeing over the last couple of years during the sunspot cycle minimum years, where there's very little, if any, sunspots. But as the sunspot activity increases and the occurrence of solar flares increase, then we begin to see some interesting anomalies that take place. So here's a couple of slides showing the sunspots for those who may not be too familiar with space weather concepts like sunspots. These sunspots on the region of the sun have the capability, depending on how complex they become magnetically, to erupt with these flares, and the flares produce this X-ray energy and ultraviolet energy. The whole spectrum of light and radio explode away from this flare and race out into space. And if the Earth is facing that flare, then the sun lit side of Earth is going to be affected by that radiation. And what happens when that excessive amount of energy hits the Earth? Well, the energy in the ionosphere increases, the ionization of the ionosphere increases. And that's going to give us this incredible opening, for instance, on 10 meters and 6 meters, an instantaneous opening. But if the flare is so huge, which occurs a few times during the sunspot cycle, it could actually completely shut down those upper bands. And that's because the D region will become so ionized that it'll absorb even up to 10 meters. And we call that a radio blackout. So the sunspot activity is a good indicator of the overall energy level of the sun as it relates to HF radio propagation via the ionosphere. The 2800 megahertz frequency, or 10.7 centimeter frequency, is where we measure radio flux. So the higher the S units of that signal, the more that radio noise coming from the sun indicates higher activity. That's how we measure the F reading in the charts that you might see. So generally speaking, with high indices, the higher frequencies propagate in the ionosphere. And as we begin to see this new cycle take off, we're seeing an increase in the higher bands, which we'll talk about in a little bit. So again, solar flares can disrupt HF propagation, and coronal holes, which are weak magnetic areas on the sun, can also degrade our HF communications. We see that a lot during the sunspot cycle minimum. And coronal mass ejections, which occur during a sunspot cycle flare, when there's a sunspot region that explodes and releases that radiation and some solar plasma, the coronal mass ejection races out into space, not as fast as the speed of light, but pretty fast. Like within a day or two, that cloud could pass the Earth, and that'll cause a disruption in our communications because of the geomagnetic field and how the geomagnetic field interacts with the ionosphere. Okay, so being aware, or better, being able to predict space weather makes sense. Remember fishing. If we know what time things are happening when we're fishing, when were those trout biting, when are they feeding, then we go fishing at the best time and in the best opportunity to catch fish. In the same way, if we know what's happening with space weather, when solar flares are happening and when there's an increase in sunspot activity, we can better plan our time. And incidentally, there are day-to-day fluctuations with propagation, and we're able to predict almost day-to-day what kind of activity we might expect on HF. So better planning of our time and understanding the current condition, and then working around that. Should I work this weekend to hunt for DX from Africa, or should I do my honeydew list and just spend my time maybe fixing up the garage or fixing an antenna? Is it really possible that I can get that African station? Or when would I be able to get that African station and then plan my time accordingly? So there's some tools. One of the tools is something called the Voice of America prediction engine, the VioCap engine. And the URL, you'll probably want to copy if you're not familiar with this, is the https:// www.viocap, That's voacap.com/HF. And some examples of that tool are, for instance, where I picked the transmitter where that red icon is, and the receiver where the greenish blue icon in California. I predicted this on a path across the United States, continental United States, in June, because I wanted to find out during field day if someone in the Northeast could work, say, FT8 with the current sunspot cycle, where we are, with about 22 sunspots predicted for June. And the result for a circular reliability is this plot, and the red indicates the frequency by time of day with the highest reliability between those 2 points. So if I wanted to work somebody in California, I would pick 20 meters, for instance, between about 00 UTC to about 03 UTC. That would give me a good 20-meter opening between the East Coast and California. And that's what this plot represents. So a tool like the VioCap tool allows me to do analysis and prediction and find out the best path conditions and time of day to hunt for a particular station or a particular state, particular country, whatever I'm hunting for. So again, talking about field day, I did a plot, a world map plot, showing a radio signal footprint colorized by reliability. The red is the highest reliability. So anywhere on that map where that deep red is, I have a chance up to 100%, 90 to 100% reliability that my FT8 signal is going to be heard by stations within that red region. Conversely, the orange area indicates the area of about 70 to 90% reliability, and so forth. So white, of course, indicates no reliability. I wouldn't have a chance to get my FT8 signal heard, say, in India during that 0800 to 0900 UTC window on 7.1 megahertz. Again, this for field day this year with 22 sunspots. Now, if I changed to 1700 to 1800 and measured or plotted the 40-meter band, it shows 40 meters is pretty much a very close regional band at that time. And I wouldn't be able to get very worldwide or even across the states on 40 meters with FT8 at that time of day. So what, I should switch to a different band. So let's try, okay, this is 20 meters, same time, 1700 to 1800 with an FT8 signal on 20 meters. I have a much better wide range that I can propagate my signal to based on this year's predicted sunspot cycle. So what can a few HF energizing sunspots, what can it actually do? Well, in April, we had some sunspots and 10 meters did come alive. This is an actual capture of a few things. This shows the sunspots that were present on 20 April. And this is the WSJTX software showing that there was a lot of activity at my location on FT8. And this was coming from different countries, mostly the South American continent, but also some just North Africa and some Europeans were coming through on 10 meters. So just a few sunspots and the bands do wake up. But if we want reliable, consistent HF activity on 10 meters, we want the sunspot cycle to be at its peak years. And we're looking at, this is our current plot with the red being predicted and the blue being actual. We're looking at about 2025 where the peak of the cycle should occur based on the predictions that scientists have come up with. So you're going to see 10 meters open from about 2024 to about 2026, probably on a consistent daily basis with DX into Europe and Asia and basically worldwide conditions during the sunlit daytime hours where you live. And if the DX is also in sunlight. Now, when it gets to the peak year in the 2025 timeframe, you could actually see worldwide, even when one of those are in darkness. And that's the magic of 10 meters when you see it open 24 hours a day and you can work the world with a wet noodle. Could that happen this cycle? The cycle is expected to be, according to predictors, about the same as last cycle. Now, what did we learn during cycle 24? We learned that even if 10 meters isn't open 24 hours a day, the entire HF band is able to propagate either by sporadic E, worldwide DX on the lower bands consistently, such as 20 meters and 17 meters being open worldwide almost 24 hours a day. But that QRP and like FT8, which is so hot right now, DX is worldwide. Now, the new question on many minds is, where are we? And have we really begun in this cycle? And the answer to that is, of course, we have, as we can see, with a slight tick between about 2020 and 2021. The 2021 has been quite active. We've even had some moderately large flares. But the scientists do predict a reasonably weak cycle compared to, say, 3 to 4 cycles ago. The National Oceanic Air and let's see, NOAA, I can't remember what the acronym means. Anyway, NOAA and NASA co-chaired an international panel to do a forecast on cycle 25. And there's a very large group of scientists with many different models. And they got together and figured out what the consensus was for the current sunspot cycle. And they're predicting that the maximum should occur no earlier than 2023 and no later than 2026. That's why that red plot on the predicted sunspot cycle chart shows about 2025. They took the median. So they're saying probably July of 2025 is when the highest number of sunspots will appear on the sun. The minimum peak that they're expecting is about 95 sunspots average during July of 2025. They're expecting a maximum peak of 115. That's a little bit lower than the cycle 24 that we just left. In addition, the panel expects the end of the cycle 24 and start of cycle 25 to occur, well, they expect it between July 2019 and September 2020, and it appears that they were correct because we do have a minimum that they're still just tweaking actually when they statistically feel the very bottom of the cycle occurred, and that should be released soon. There is one scientist that is predicting against the other consensus a very large sunspot cycle this time around. And his model is convincing. His model predicts pretty accurately, mathematically, that each of the previous cycles would evolve and the length of those and the strength of those cycles would occur in a certain way. That's what his model was predicting. Well, as he applied the data to his model, those predictions were accurate to what actually happened consistently, cycle after cycle. So his conclusion is, if I've got a model that could predict past cycles and fit the data of what really happened, then this current cycle may well follow that same model. And his model predicts that this cycle will be breathtakingly maximumed up in the 200s to something that we haven't seen in, say, the last 100 some years. Now, if that occurs, 6 meters will be hopping daily worldwide, because that's very, very high activity, energizing the ionosphere in incredible ways. And it'll truly be magic. But will his prediction come true? And that's the question right now on a lot of people's minds. Most scientists are predicting the week cycle. We only have models, so all the predictors are just looking into a crystal ball, and we don't truly know what could happen, and we won't know until it actually happens. And I say all of this going back to the fishing illustration. We have models that tell us what could happen. We have tools that are telling us what is happening, and reasonably in short range, what we can predict, what time of day we expect openings between our location and a remote DX location. So we can leverage those tools and this information and knowledge and begin to tailor our on-air activity, tailor the time we hunt for a DXpedition, times for a DXpedition to actually go and do the DXpedition and yield the maximum yield of DX stations. And that's the key to the new cycle. I'm not going to sit here and try to validate, say, the prediction that we're going to see the greatest sunspot cycle ever seen in our lifetime based on that one scientist and his model, nor am I going to sit here and advocate what the consensus of scientists are saying. But I am going to advocate that if you don't get on the air, first off, you're not going to yield anything. But don't waste your time just hunting and pecking, as it were, just throwing your lure out into some water and hoping some fish comes along and bites. The chances of catching something is pretty low that way. If you tailor your time and where you operate based on these best tools and best knowledge, you're going to have the greatest success and the greatest satisfaction as an HF user. If you're new as a ham and this is your first sunspot cycle as an amateur, what do we expect the rest of this year? We're going to expect an increase in daily sunspot activity. We're going to see an increase in solar flares. We're going to see an increase in geomagnetic storms. But certainly because of that, we're going to see an increase in DX on higher bands, but a wider variation in conditions. So you may find some days DX is hot, just corner to corner of the world, from edge to edge on the bands, lots and lots of DX activity. But then the next day, there's nothing on that same band at that same time. And the reason for that is space weather and the variations that are occurring as the sun wakes up. Geomagnetic disturbances, flares, things that affect the ionosphere in such a way as to either increase propagation or shut propagation down. I would have loved to get a lot more into the science and a lot more into delving into the models that these scientists expose to the public, but we don't have time in about a 40-minute, 45-minute talk. So I invite you to read the columns that I write in CQ Communications and Popular Communications magazines. I write for both magazines, and I cover the topic from a science viewpoint as well as a user amateur radio viewpoint. I also report on current conditions and what we're expecting, and how those things relate to our daily operation. So I invite you to those publications. And incidentally, the electronic version of CQ magazine always comes out on time. I know there's some people that have some bad taste in their mouth because CQ, the paper version, can sometimes be late, but the electronic version is never late. It always comes out on time and everything is fresh and relevant. The other thing that I'd like you to do is explore Carl K9LA's talk about the current sunspot cycle and its prediction. He delves just a little bit more about the models, but he says generally the same things that I've been saying about how to expect changes on HF and why those changes occur. But the address for that is, and that's actually could be HTTP or HTTPS, it works both ways, g.nw7us.us/2021 uppercase SSC as in Sierra Charlie 25. And that will redirect you to a YouTube video of Carl's talk. I invite you to check that out. Carl and I both work with writing about space weather, and we've at times even been part of the ARRL bulletin. You can also join a Facebook group if you're on Facebook. It's spacewx.hf radio after Facebook. That's the URL. And shortly, we're going to resume posting daily images of the sun in different wavelengths, different charts showing current conditions. If a solar storm is happening, we'll post bulletins on that, and it'll be pretty much live data feed all day long, every day. So I welcome you to that as well. I also have a YouTube channel. It's just my call sign. And that's for this production. Let me turn this off again. For this presentation, I'll wrap it up and we'll start taking questions. But space weather is an amazing thing, and it's a current huge topic for many different services because, again, going back to the beginning of this talk, the infrastructure is at risk because of large solar flares and geomagnetic storms that can induce currents on pipelines and power grids. Governments are concerned with this new sunspot cycle if we're going to have massive power outages and problems that our infrastructure just can't handle. So lots of money from governments are being thrown at space weather, and we amateur radio operators benefit from that because greater understanding and greater knowledge is available for us to leverage in our planning, in our understanding of what's going on in space weather and the sunspot cycle. So 25 is going to be exciting on many levels. And again, it should stop. So now I'm ready to take questions, but again, I can't share my video of myself.
We got your audio and we've got your photo. That's right. Pretty good.
So, and we've got a couple of questions. One common request: you had a number of URLs in your presentation. Can you post those on the chat line? Because people, they're long and they didn't write them down, or they didn't get them in that form. So if you can just post your URLs on the chat line and send them to everybody, that would be appreciated.
You bet.
Also, somebody asked for a copy of the presentation. All of these presentations will be available on the convention website. They're all being recorded as we speak, and you'll be able to view those after the convention to your heart's content. We'll have them up for a while. We had one question about that you actually addressed about CQ print magazines. We understand the digital versions.
Yeah, I
the
knew
letter
that question was
and
going to
the
come up.
version has its problems.
It invariably comes up every time I go into public and they hear that I'm an editor. First off, I have absolutely no internal knowledge nor control of anything that goes on at CQ Magazine. I'm a contributing editor. I write my column, I submit it, and that's all that I know.
Yeah, I understand. But you also understand there are people that are frustrated.
Sure. Yeah, I've even been frustrated, no doubt.
Any other questions from anyone? Raise a hand or post it on the Q&A line.
I think at the beginning of your presentation, using your fishing analogy, folks thought, well, maybe we're not going to be catching much fish this year, but you certainly turned that around during the presentation. So thank you for doing that. There are a couple people who have their hands raised. Here's Norway Kilo 2 Romeo. I've activated your microphone. Do you have a question for Thomas? Norway Kilo 2 Romeo, you're live.
You need to unmute
You have
yourself.
to unmute yourself. NK2R. Okay, well, let's try Dick Norton. Nick, Richard, do you have a question? If you so, you need to unmute yourself. Well, they raised their hands, but they're staying silent. Anybody else have?
We have one question on the Q&A line. Is there a real-time propagation page anywhere?
There are a number of them. First off, the Space Weather Prediction Center, NOAA, provides a live space weather page. I provide a collation, but it's out of date in terms of its presentation. I have some programmers working on it right now to overhaul that, and we're trying to get that released by summer. And I'll be writing about that in my column and also on my website, which is my callsign.us, nw7us.us. All of these are under construction, and by summer, everything should be live. That Facebook group also will provide live hour-by-hour details posted to that Facebook page, giving information on what the sun is doing. I also have a Twitter outlet. I'll put that in the chat line. There's an hourly group of tweets that go out that tell what current space weather activity is happening, the solar flux, the sunspot number, the speed and direction of the solar wind, the geomagnetic activity, and if there are flares and whatnot, those are posted as well. So there's actually quite a few resources, and I provide some of them that can be out there. Even ARRL has a little bit in their propagation links page.
Okay, we've got a question, a real basic question here. A numbers and K numbers, what do they mean and what's a good number?
Yeah, see, I thought maybe I would talk about that and give a primer, but I skipped some of that because of time. The A index, generally speaking, is an average of the geomagnetic activity over a day's time frame, while the K index is more granular and gives us an average of a 3-hourly period number of the geomagnetic activity level. The lower the levels, the lower the geomagnetic activity. So I'll take a few minutes and explain why that's important. The ionosphere is a region with those different layers, the E layer, D, the F layers, and the ionosphere is made up of ions that have been stripped away from gas molecules. The more solar radiation, the more of that separation between molecule and ions. And so we have an ionized layer of the atmosphere that envelops the Earth. Well, the Earth is also enveloped by a magnetic field. Like a bar magnet, we have a north and south pole with these rings of magnetic flux lines going from pole to pole. Those field lines intersect the ionosphere. If those field lines are stable and they don't fluctuate around and they're just strong, straight, steady lines, the ionosphere is settled. It's not active. It's quiet. But when solar plasma and solar wind bombards our magnetosphere, it causes the magnetosphere to churn, to get chaotic, the field lines get all erratic. And that causes the ionosphere to lose its energy. Recombination of the ions to the molecules occurs and ionizations decrease. So the greater those numbers, the A index and the K index, the more active our magnetic field around the Earth is, the more our ionosphere becomes degraded, or the lower the propagation points between a circuit from city to city, for instance. That HF propagation, the maximum usable frequency, that's lowered because the geomagnetic field has become active to stormy or whatever. Does that help?
I hope so.
Yeah.
Here's a question. Should we be especially worried in this sunspot cycle that geomagnetic storms will be so great that there'll be equipment damage?
I believe that it is possible. It's really difficult to ascertain how well our infrastructure has been improved over the last few decades and whether or not we could withstand a very large solar storm similar to one that we saw in the late 80s that shut the power grid off in the northwest part of North America. Parts of Canada and parts of the United States actually lost power during a very great giant solar flare that spewed out a very large cloud of plasma that hit directly the Earth's magnetosphere, generated that electric charge on the infrastructure, and broke equipment. We've also seen satellites occasionally damaged or at least temporarily taken offline during certain solar storms. I don't think our infrastructure is so bulletproof that we won't see something happening during this cycle.
Okay, well, I think we're out of time for this presentation. We're going to take, there's still a couple of unanswered questions on the Q&A line. John, can you send those to Thomas offline?
Yes.
And
Yes.
you can answer those directly to the people that, that posted them.
Exactly. Thank you very much, Thomas, for your presentation. It was very enlightening, and also for the other references that you gave us as well. There's a lot of reading material, a lot of good references.
You bet.
Thank you.
Okay.